This lesson is to teach you how to create a scatter plot with a graphing calculator. There's a sample problem at the top, and it gives you step-by-step directions for how to clear entries into list 1 and list 2, how to enter your data, and how to view a scatter plot, needing to make sure that it's turned on and that you can see your scatter plot after you've entered the data. There are step-by-step directions for you to try this. On the inside, we're looking how to find the line of best fit. And to do that, the reason that we do that is so that we can make predictions based on data. So there's, again, step-by-step directions to get the equation of the line, and for the line of best fit, this data is not going to go through every point. It's going to just show you a trend. It's also called a trend line. So then, based on the line of best fit, we're going to use a scatter plot to answer these questions. How many hours would a student have to study to get a score of a 90? Well, I'm looking at a score of a 90, and I'm scrolling over to the number of hours, and it looks like it's going to be about 25 hours. If a student studied for 30 hours, what will their test score be? This is according to the line of best fit. I would not select 90 because that's only one student. That dot is one student. They should make, that's almost 100, so maybe like a 99 or a 98. How many hours would a student have to study to get a score of a 70? Looking at a 70, looking over, it's about 10 hours. And then if they studied for 15 hours, going up, they'd make a score about 75. So now we're using our data in this table to answer the questions. This is talking about the cost of a catered lunch brunch for different numbers of people. Well, what's the slope? You can do this in the calculator. So we're going to put in, get my calculator, put it into your calculator, into the stat, enter, and I clear out my values. 12, 18, oh, not here. 12, 18, 24, 30, 36, 42, 192, 288, 384, 480, 576, 672. Okay? And we're going over to calc. Oh, stat, calc, 4, enter. And the slope, we know that that A is the same as the M, so our slope is 16. And what does it mean? Well, it costs $16 per person for lunch or brunch. Writing the line of best fit, we actually just did that. Y equals 16x. You could put plus 0, but you do not have to. And what is the cost for 120 people? We're going to plug in 120 for x, because x is number of people. Y equals 16 times 120 is 1920, so it costs $1,920 for 120 people. Okay, and then look over here, predicting the intercept. Okay, so it's about a little over halfway through, so maybe 36,000. Pick 2 points that fit on the line. So I'd say 10, 50,000. And 25, 70,000. Calculating slope given those points. Let's see. I'm doing it in the calculator. You can do it also by hand using slope formula. It's about 1,333. So the line of best fit in slope-intercept form, y equals 1333x, and then plus it says 36,000, according to that graph that we looked at. Now let's predict the number of, predict the salary based on 30 years. So 1333 times 30, and then add 36,000 to it. It's about 75,990. So after 25 years, so we're plugging in 1333 times 25, add 36,000 to that, 69,325. This is all money. All right, now it says use the graph. Predict the years if they're making $50,000. We said about 10 years. I used the graph there. And then use the graph, predict the number of years. If they're making $85,000, scrolling over, about 35 years. So then we're looking at this next table. It's active woodpecker clusters in this area of the National Forest in Mississippi. We know that time is X, so that active clusters is Y. We're going to plug these in again to your calculator. Okay. Clear your values. 1992, 1993. And your Y values. Go to Stat, over to Calc, and number 4. So it's about, slope is about 3.6. What does it mean? It means that there is an increase of 3.6 clusters per year. So then write the equation given that in your calculator, y equals 3.6x minus 7218 is about where it goes. And then predicting number of clusters in 2010, 3.6 times 2010 minus 7218. Oh, hold on. Let's see. Okay, this should not have been correct. This should have been 7350. I don't know what happened there. And if I plugged in times 2010 minus 73, this is not correct. Hold on. That's because this should have been a 7. My fault there. Make that a 7. There it goes. That should have been better. All right, now plug in 2010. Is 7437 minus 7350. There it is, about 87 clusters. All right, then let's look at the scatter plots. What type of scatter plot? To the right, it's going negative. It's going downhill, so this is a negative correlation. Circle the graph that represents the line of best fit and explain why the others are incorrect. This is beneath the data. This is not steep enough. This is perfect. This is the line of best fit. Oh, can't see that. Okay, that goes right through the middle of the data. This would have had to be steeper to go through all the data, and this is just set too far underneath the data.